my name is Joel Friedman. I'm a junior studying computer science at Alabama A&M. We're here at the Special Project Laboratory, which is a student-run organization. We have two main projects we do. The first one is Formula SAE, where we have to build and engineer our own race car, and we can see that right over here. So every year we have to build a new car from scratch. We have to make our own chassis. That's one of the requirements. Formula SAE is a very prestigious engineering organization. Here is the car we're currently working on. Hopefully we'll be able to go up to Michigan and compete in, I believe, May. Here you can see Sam, one of our teammates, is working on the wiring harness. He's just about finished with that. And this is the chassis of our car that was welded, I believe, by Drake University across, down the street. I'm part of the brake system, so I'm going to be helping install the brakes and do all the calculations to make sure it's safe. Also working on the SES, which is the structural integrity spreadsheet. Yes, it's a very cool competition. It has 120 teams from all across the country, and we're the only HBCU competing. So the next project we have is the NASA rover competition, where we have to build our own rover. It's kind of simulating the terrain and problems you'd run into on Mars. So we have to build our own rover from scratch every year as well. We're doing RC, so it's going to be remote controlled. I am the one who designed the wheels. I'm also working on some of the sensors, where we're making... The sensors I'm working on is we have to monitor the rover speed and GPS location, and we also have to there are several tasks we have to do. So some of the other teammates, they're doing the water collection and soil collection, where we have to collect the soil sample and water sample and do some measurements on it. And I can show you one of the wheels I made. So this is one of our wheels for the rover we're building. I designed this in SolidWorks, and after that I used the resin printer to print the whole wheel. Then for this tread up here, this was made separately. I made a mold using SolidWorks. Then I started pouring polyurethane into the mold, and piece by piece glued them together. And yeah. So this is last year's rover. As you can tell, the wheels for this year are going to be much bigger. Back wheels are going to be much bigger. The front ones are going to be pretty similar size. So what we're doing this year, it's going to be similar to a lawnmower, where the front wheels are going to be on a caster, so they're going to be free spinning, but the back wheels are going to have the motors attached to them. So that's where all the traction is going to be coming from. And that way we'll be able to do 0 turns by turning one wheel forwards and the other wheel backwards, because each motor is going to be independently connected to the back wheel. Last year, we struggled to get over some of the obstacles NASA had on the obstacle course. So this year, I think a much bigger and wider wheel with much deeper treads will be very beneficial, and hopefully we'll be able to complete all the obstacles. All right, so this is one of the things I'm working on for the rover competition. So here I have an Arduino, which is like a microcomputer, and a breadboard, which gives power and ground, where you can have a shared power and ground for the microcomputer. So this is the GPS sensor, the GPS module. So this is what's going to let us get the GPS location of the rover, which is one of the requirements for the competition. How this works is it hooks up to the satellites, and from there it gives us the longitude and latitude. And I'm using radio waves, which will be transmitting that data wirelessly to my laptop. So that way we don't have to retrieve the data from the rover. It's more simulating how to be on Mars, where you're going to receive the data wirelessly. I believe we have to update the location at least twice every minute during the excursion. All right, so the reason I chose to work on this task specifically is because I'm a computer science major, and there is programming involved, so that gives me some experience of what I'll be doing in the field when I graduate. Yeah, basically the Arduino lets you upload code that's going to control what the sensor is doing, the GPS monitoring sensor. So the way I kind of figure out how to do this is I found some tutorials on YouTube on how to use the Arduino, breadboard, and last year I worked on a rangefinder, which was pretty similar setup, and that would let you see the location of how far away something is from the rangefinder and display that data back to us. That year I used Bluetooth. I hooked up a Bluetooth module so we could receive it wirelessly, but I ran into a problem there because lots of people have Bluetooth, so the signal was kind of getting disrupted. So that's why this year we're going to be using radio waves. It should be much more, should be a stronger signal and less chance of it disrupting. I'm really hoping we can place in the top 3 at the competition. That's my goal. I'm in charge of the rover project, so that would be a very big accomplishment for me if we were able to get in the top 3. For me personally, my goal is to improve my programming skills and go into the workforce as a software engineer. So we're going to our other workshop. One of our technical advisors, Gary, when he first came and joined the project, he wanted to show off a little bit, so he made a car, which we're going to go check out right now. Oh, this is Gary Chan. He's the one who made the race car. We're about to go check. And this is the mold I used for the tire tread on the Rover wheels. This is like our extra workshop. We have more instruments and materials. And this is the car what Gary made when he first joined the project. I think he finished this in 4 or 5 months, which is very impressive. Gary is a very good mechanical engineer. Yeah. I redesigned it because I found this pattern online from different rims that were currently being made. So this looked like a good design to me. So I recreated it in SolidWorks. Then we put in a little bearing in here for the adapter. So then we can put a screw all the way through and then attach to the top of our caster. And it's going to be free spinning. When with these big back wheels, the motor is going to go through here in the middle. And it's going to be turning. We're going to connect it using these 4 bolt holes. And these are little adapters I made. I also resin printed these. They're going to make sure what the bolt is snug inside these holes. Because originally we were going to use a chain and run the wheels indirectly with the motor. But we decided to switch and have the motor attached directly to the wheels. So I printed out these adapters. So everything's going to be very firm in place with no wiggling or looseness. Same thing here. I made these wheels using SolidWorks. Once I've had the design ready, I went to the printer and believe it or not, this came out of here. And like I said earlier, with the tread, I used polyurethane. I found this tread pattern, the V-shape, came pretty highly recommended online for off-road activities because we have to go over inclines with loose soil, rocks, pebbles, and we need to try to get over all those obstacles to get as many points as possible. Yeah, once the treads were ready, we super glued these on here. Yeah.